Okay, this is your Chapter 6 final exam preparation on fractions. All of your outcomes with fraction sense. And the first 6 questions are true-false questions. So the first one says the product of two proper fractions. And I did define it for you just in case you weren't sure what I meant by proper fractions. And a proper fraction, for example, like 1/2, 2/5, 3/4. Those are all examples of proper fractions where the numerator is smaller than the denominator. Another way to say it is just numbers that are less than 1. Numbers less than 1 is really, right? Numbers less than 1 are proper fractions, really, when we talk about just regular fractions. So if you have any of those fractions, 1/2, 2/5, 3/4, or whatever you can make, if you multiply them together, so let's just take these two, for example. When you multiply two proper fractions together, is it possible to get something that is greater than 1? And the answer is no, it's false. And here's why. Because when you have the first number being a fraction, this is going to be a part of whatever this second fraction is, because this word is of, right? So it's a part of a second fraction. And if you have a part of, let's say, 2/5, so if I take 2/5 here, this is 2/5. And this is less than 1. But the first one is going to be a part of that. So instead of having all of 2/5, I'm only going to be able to take half of 2/5. So since your starting number is always going to be less than 1 since it's a proper fraction, and you're going to be taking a part of that, in essence, whatever this part is, if you take a fraction of it, your answer will always be even less than the second fraction, because you're taking, in this particular case, only half of 2/5 as opposed to doubling 2/5 or tripling 2/5. You're only taking half of it. And in every case, you're going to end up with an answer that's less than 1. And the second question says half of 3/8 is greater than 1/4. So half of 3/8, written as a multiplication of fractions, would be interpreted as being half times 3/8. And when you do that, you're going to end up with an answer of 3/16. Since 4/16 is actually 1/4 in lowest terms, then 3/16 has to be less than that, and therefore half of 3/8 is not greater. It is less than 1/4, and therefore is false. Question 3, the reciprocal of 1 3/8 is 11/8. Well, in order to figure this out, you cannot examine a mixed fraction as a reciprocal, so you got to change this to 11/8. This is the improper version of 1 3/8, and the reciprocal would therefore be the flip, where you swap the numerators and denominators, which will be 8/11. And therefore, the answer for this is false. The reciprocal is not 11/8. The reciprocal is 8/11. The improper fraction is 11/8, but not the reciprocal. Question 4, a good estimation for this. Now, here's how I do this. And on your test, I don't think I'm going to ask one of these questions, but we'll see anyway. Think about money. So 2 and 1/5, if I thought about money, would be $2 and 1/5 of a dollar. And 1/5 of a dollar is 2/10, which would be 20 cents. So $2.20 divided into piles of 25 cents, which is what 1/4 is. How many piles could I make? So if I think about money and dividing into piles, if I have $2.20 divided into 25-cent piles, 4 of them, well, I'm not going to use that. 4 of them, 4 25 cents would make $1. Another 4 would make another $1. And this is a terrible drawing. Okay, forget this drawing. If I had 25 cents, I could make 8 piles, and that would be $2. And I could almost make one more pile. So if I had $1.20 divided into 25 cents, I can make 8 piles, which is $2, plus almost another pile. So the answer would be 8 and something. Some fraction part, right? So that would be a good estimation. But the actual question says is a little more than 10. Not that 10, then 10. So therefore the answer is false. It's a little bit less than 9 as opposed to a little bit more than 10. I know question 4 sucks, so we won't even bother worrying about it. If you didn't get it, don't worry about it. It's not on your test, so let's not get too worked up about it. Question 5 says 3.5 multiplied by 3/4 is greater than 1.25 plus 1.5. So here, if we look at this, I'm going to go 7/2, which is the improper fraction, multiplied by 3/4. When I multiply that out, I'm going to get 21/8, which as a mixed fraction is 2, that's 16, plus 5/8. So just a little bit more than 2.5. Over here, when I add them together, I'm going to get 5/4 plus 6/5. You know how I like to always work with improper fractions. I get 25/20 as an improper fraction. I get 24/40. I get 49/40, which is or 20ths, which is 2, and 9/20. This is a little bit less than 2.5. Less than 2.5, and this is more than 2.5 because, of course, 4/8 is half. So 5/8 would be a little bit more than half, and 10/20 is half. So 9/20 would be less than half. So therefore, this is going to be greater than 2.5 than 2 and 9/20, and therefore it's true. And finally, in your true/false, multiplying a fraction by its reciprocal will always be 1. Let's check. Let's take any fraction. Let's take 1.5. Okay. So if I multiply it by its reciprocal, I have to know first of all that, well, 3.5 is actually, or 1.5 is 3/2. Its reciprocal would be this, right? So if I multiply 1.5 by its reciprocal, I would end up with 6/6, which is equal to 1. Ooh, that one worked out. What if I took 1/4 and multiplied it by its reciprocal? Its reciprocal would be 4/1. That would give me 4/4, which is 1. So therefore, the answer is true. Whenever you multiply a fraction by its reciprocal, you will always end up with the answer of 1. Now, the rest of the questions are just straightforward calculations. So what's 3/8 times 5? Well, 3/8 times 5/1 would be 15/8, which is 1 and 7/8. 2 and 5/6. So I'm going to change 2 and 5/6 to an improper fraction, which is 17/6 multiplied by, remember, whenever you have a whole number, it's easiest to think of it as being a fraction over 1. Therefore, you'd get 51/6, which is equal to 8, which is 48, and 3/6, which is 8.5. Now, obviously, if you cross-reduced it here, 1 over 2, you end up with 17/2, which is 8.5. Same answer, just an easier way to get the answer. Next question is 5/6 divided by 2. So 5/6 multiplied by the reciprocal of 2, because we never do division. So since 2 is 2/1, its reciprocal will be 1/2. Multiply the numerators to get 5. Multiply the denominators to get 12, and you get 5/12. That's your answer. Next question is 3.5 divided by 4. For this one, I'm going to change my mixed fraction to 7/2. Multiplied by the reciprocal of 4. Since 4 is 4/1, the reciprocal is 1/4. Multiply your numerators and multiply your denominators, you get the answer of 7/8. So 3.5 divided by 4 is 7/8. Your next question is a multiplication. So the real reason I'm asking you this question is, can you cross-reduce? It's a great one. So 3/15. If I thought 3/15 is a regular fraction, I can reduce it down to lowest terms of 1/5, which means this will become 1, and this will become 5. And if I think of being 14/7, this in lowest terms will be 2/1, so I'm going to make it 2/1. And now when I multiply my numerators, I get 2, and when I multiply my denominators, I get 5, so my final answer will be 2/5. But if you didn't cross-reduce, that's okay, because if you didn't cross-reduce, to get the answer 2/5. I'll put 2/5 down here. You would get 3 times 14, which is 42, not 52, 42. And 7 times 15, which is 105. Now the difficult part is you don't know probably that you can divide this by 3 and this by 3, because 4 plus 2 is 6, and 6 is a multiple of 3, so 42 is divisible by 3. 1 plus 0 plus 5 is 6. 6 is a multiple of 3, so 105 is divisible by 3. 42 divided by 3 is 14. 105 divided by 3 is 35. Once we get it down to 14 over 35, a lot of people didn't know that you can divide this by 7 and this by 7, giving you 2 over 5 as your answer, which is what I had before. Next question, 1/2 times 4/5. If I multiply the numerators, I get 1 times 4 over 2 times 10. 2 times 5, excuse me. I get 4 over 10, which in lowest terms is 2 over 5. If I cross reduce, I went 4 over 2 is 2 over 1, and ended up with 2/5 anyway. Your next question is a mixed fraction times a mixed fraction. Change them both to improper, so this would be 12/5 multiplied by 5/3. Obviously, right now is a great time to cross reduce, because if you do, 5 over 5 will become 1 over 1. 12 over 3 will become 4 over 1, and we'll end up the answer of 4. But if you didn't cross reduce, you got 12 over 5 multiplied by 5 over 3, which gives you 60 over 15. Both are divisible by 15, which would be 4 over 1, which equals 4. The next question is 2 over 9 divided into groups of 2/5. So remember, we keep our first fraction, change to multiplication, and use the reciprocal. This is actually quite an easy question for 2 reasons. A cross reduce is really nice because 2 over 2 is 1 over 1, meaning your answer is 5 over 9. But you didn't have to think of it as a whole number. You didn't have to think of it as a mixed number. It just worked out really well. Now, if you didn't cross reduce, you would have had this question, times 5 over 2. You would have got 10 over 18, which reduces down to 5 over 9. Your next question, 1/2 divided by 4/5. Mixed fractions are awful, so change it to improper. Change the multiplication by the reciprocal, and you end up with this question. Multiply your numerators, you get 15. Multiply 2 and 4, you get 8. That becomes 1 and 7/8 as a mixed fraction. Your next question, 2 1/4 divided by 1 3/10. Remember, mixed fractions are the devil's playground. I don't know what the expression is. 2 1/4 will be 9/4 divided by 13/10. Again, keep your first fraction, change the multiplication by the reciprocal. If you cross reduce, it's beautiful, but let's not cross reduce first this time. I get 90 over 52. 90 over 52, both are even numbers, divisible by 2. That's 45 over 26. That would be 1. And 1926 is a final answer. If you do cross reduce, both are divisible by 2. You get 5 over 2, which ends up with 45 over 26, which still gives you 1 and 1926 as a final answer. Now we get into your BEDMAS questions. Don't forget, if you have a difficult time, just remind yourself by writing it down somewhere. Underline that there's 4 steps, not 6 steps, and make sure you do them properly. So the first one we do in this particular one is the multiplication. So if I were you, I would write down 1/5 plus, and I would multiply this. 1 times 3 is 3, and 2 times 5 is 10. Do not put 3/10 first. It's still the second term in your expression. 1/5 plus is still the first part of it. Now you have addition, which is a grade 7 outcome. Common denominators, it's going to be 10. Equivalent fractions is this. Add your numerator and keep your denominator, giving you 5/10, which in lowest terms is a half. Your next question is 1/3 take away 1/10 times 1/2. Again, pretty simple. Just make sure you do your multiplication first. Bring that down because you're not going to do it yet. 1 times 1 is 1. 10 times 2 is 20. So I have 1/3 take away 1/20. Now some people said you can't find a common denominator if you have 3 or 20. Well, you can always find a common denominator by multiplying the two denominators that you do have together, and you get a common denominator. Sometimes it's not the lowest common denominator, which simply means at the end you have to reduce your fraction. But in this case, 60 actually happens to be the lowest common denominator that 3 and 20 share. So the equivalent fraction to this is going to be 20/60ths, and the equivalent fraction to this is 3/60ths. Keep your denominator and subtract your numerator. Your final answer will be 17/60ths. Moving along to the next question. This time we have 3 operations. The first one's in brackets, which means you have to do it first. So subtraction requires a common denominator, an equivalent fraction. Subtract those, you get 11/20ths as your answer for the brackets. The rest of this, I'll highlight it for you. The rest of this right here comes straight down. Okay, we're not going to change it. We're going to keep it where it is, and it comes straight down from where it was. Now I have 2 operations. I have an addition and I have a multiplication left. I got to do multiplication first, which means I have to do 3/4 multiplied by 1/5, which if I multiply the numerators and denominators, I get 3/20ths. And this is beautiful because right now I'm adding them in my last step, but they already have a common denominator. Keep your denominator and add your numerators. You get 14/20ths, which is not in lowest terms because both are divisible by 2. You get a lowest term answer of 7/10. Your next question. Now we have 3 operations here again. Mixed fractions, you need to automatically change them to this. So the first thing I'm going to do is just rewrite this whole thing as such. Okay? Now, oh, no, sorry, I forgot 1/2 is going to become 3/2. Oops, daisy. Now I'm going to multiply first. So I'm going to multiply this first. And if I want, I could multiply this together too, and then just keep the plus sign between the 2 multiplications. So over here, I'm going to get 26/15ths. And over here, I'm going to get 3/30ths. I'm going to keep the addition sign between them. I need to add them, which requires a common denominator. 30 is going to be the first multiple they share. So the second fraction, 3/30ths, is going to stay 3/30ths. The other one is going to become 52/30ths. Keep your denominator. Add your numerators. You get 55/30, which is equal to 1, and 25/30ths, which is equal to 1, and since both are divisible by 5, 5/6 in lowest terms. Your next question is your story problem. It says Aaron makes $12 an hour, Billy makes 1 1/4 times as much per hour as Aaron, and Carl makes 2 1/3 times as much as Billy. How much does each make per hour? So I'm going to use A, and I'm going to use B, and I'm going to use C because Aaron, Billy, and Carl are all A, B, C. So right off the bat, all he had to do was write down $12 for Aaron, and that's how much he makes. But Billy makes 1 1/4 times as much as Aaron, which is 1 1/4 times 12. The way we're going to solve this is we're going to change this to this fraction, and we're going to keep 12 as over 1. Multiply the numerators to get 60, multiply the denominators to get 4, and 60/4 in lowest terms is 15/1, or just 15. And therefore, Billy makes $15 an hour. Carl makes 2 1/3 times as much as Billy, not Aaron, but Billy, which means 2 1/3 times 15. 2 1/3 is 7/3 multiplied by 15/1. This time I'm going to cross reduce because I probably should have did in the last one. But 15/3 will become 5/1. And once I cross reduce, multiply my numerators to get 35. The denominator equals that. Therefore, Carl makes $15. So finally on your test, you would go, therefore, Aaron makes $12. Billy makes $15 an hour. I should put per hour. And Carl makes $35 per hour. Next question out of the basketball game. It's supposed to be 600 people, so I'll scratch this out. We changed it on the test. 600 people were in attendance. 1/5 were men, 1/3 were women, and the rest of them were children. What fraction of the people at the game were children? So there's two ways you can do this. The first way is to take the fraction of men and add it to the fraction of women. Okay, so I do 1/5 plus 1/3, common denominator maybe 15. This would be 3/15 and 5/15. The fraction of men and women is 8/15. So if that's all of the men and women, just over half of them are men and women, and the rest are children, therefore the rest, which is 7/15, are children. Or 100% of the people in the audience, which is 15/15, take away men and women will equal children. That's one way you could have did it. You could have just said, well, 1/5 plus 1/3 is 8/15. And since that's men and women, the rest have to be children. It doesn't say how many are children. It says what fraction of the people are children, which is different. The other way you could have done it is you could have added, found out what 1/5 of 600 is. And 1/5 of 600 would be 601 and multiply. That will get you whatever 600 divided by 5 is, which is 120. So 120 are men. Women is 1/3, so 1/3 of 600 would be 600 over 3, or 600 divided by 3, which is 200 are women. Therefore, since the rest are children, if you add up the number of women plus the number of men, that's 320. And therefore, all of them take away the 320 means that 280 of them are children. And therefore, the fraction that are children, we could say 280 out of 600 is a fraction that is children. And if I reduce this to lowest terms, we would find out that it's still going to be at 7/15, I think it was, if we reduce it down to lowest terms. Your last 4 questions are your modeling questions. Says check your answer. Check your answer simply means use your procedures to your algorithm for finding out the answer to the multiplication. So the first one is I'm going to draw 5/8, 1/8, 2/8, 3/8, 4/8, and 5/8. I'm then going to take this and I'm going to clone it 5 times. There's doubling it, tripling it, multiplying it by 4, and multiplying it by 5. And then I'm going to ask myself the question, how many 8s are there altogether? Well, there's 5 here, there's 5 here, there's 5 more 8s here, and 5 here, and 5 here. So there's actually 25 8s altogether, which is, as an answer, 3 1/8. Check my answer. Keep 5 over 8 as is, multiply by 5, which is 5 over 1. You get 25 over 8, which will work out to be your answer of 3 1/8. Next question, 4/5 divided by 3. 4/5 will stay 4/5, and you will multiply by the reciprocal of 3. And since 3 is 3 over 1, its reciprocal will be 1/3. Multiply, oh, hang on, I have to model this. Oh, well, I'm checking it first. 5 times 3. Your answer should be, once we draw this out, 4/15. Oh, I did this backwards, but whatever. So if I have 4/5 of a chocolate bar, 1/5, 2/5, 3/5, 4/5. 1/5, 2/5, 3/5, and 4/5. And if I divide it between 3 people, and I'm going to say this is mine, this is my wife's, this is my son's. How much does each person get? Well, this would be the size of each part if it's divided into 3. There are 1, 2, 3, 4 parts out of 15 in total, which makes 4/15 our answer from the drawing as well. 1/5 times 3/4, when you model it, you need to interpret the multiplication symbol as being of. So really we want to think of this being 1/5 of 3/4, which if I think of what I'm going to draw 3/4 of something. In this case, a chocolate bar right here. So there's 1/4, 2/4, and 3/4. And I get to keep 1/5 of the 3/4, so I'm going to cut it into fifths. And this check mark represents 1/5 of the 3/4. So it used to have a denominator of 4, and now it has a denominator of 20 parts. 1, 2, 3 parts of which I get to keep. So my answer is 3/20. If I multiply my numerators and multiply my denominators, I also get the answer of 3/20, but this is the picture right here. And finally, I believe your last question is your mixed fraction question. What is 2 1/10 multiplied by 1/2? So remember, for this one, we used our area model. And we used 2 1/10 as the length of the rectangle. And we said 1 1/2 as the width. And instead of the area of the rectangle being 2 1/10 multiplied by 1 1/2, I'm breaking it into 4 different parts, an A, B, C, and D, each of which has a smaller area that when I add together will equal the same as the product of 2 1/10 times 1 1/2. So A is 2 by 1, which equals 2. B is 1/10 by 1, which equals 1/10. C is 2 times 1/2. And when I double a half, I end up with 1. And D is 1/10 by 1/2, which is the only time I have to think here is 1 times 1 is 1, 10 times 2 is 20. So each of the parts end up being that. When I add them together, 2 plus 1 plus a 10th plus a 20th, well, these two whole numbers can just come down as 3. And 1/20 and 1/10 can be added using common denominator. So 2/20 plus 1/20 is 3/20. Bring that 3/20 down to the 3, and I end up with my answer of 3 3/20. Check our answer. Change this to 21/10 multiplied by 3 over 2. This becomes 63 over 20, which is an improper fraction, and a mixed fraction would be 3 3/20. Okay, good luck with everyone for your test on Monday. I hope you all do well.